So our next lesson in section 11.4 on the fundamentals of probability is about empirical probability. Well, what is empirical probability? Sometimes you might say it's just an observed probability. It's what you see. So for instance, in our classroom, if I said, what's the probability of men to the total people in the classroom? Well, then I would count the young men in the classroom. I think we have about 12 just looking around the room. And therefore, I would say that the empirical probability is 12 divided by 28, where the 28 represents the total number of observations or the total number of people in the classroom. So another way to think of this is this formula here, where it's frequency over the total number of trials or observations. And by frequency, it's the frequency of occurrence of what you're looking for. So in our brief example, we said there were 12 men compared to 28 total people. And so the probability would be 12 28ths or 3/7 if you reduced it. So the probability of being a man in the statistics classroom would be 3/7. So what I am looking at are problems number 61 through 66 in your textbook. And I'm looking at the table which represents the number of people in the U.S. who moved in 2004. And please note that the data is in millions. And so based on that, we know the number of owners of houses who moved in the same state, a different state, or a different country, and the number of renters who moved in the same state, different states, or different countries. And what we want to do is find the probability expressed as a decimal rounded to the nearest hundredth that a randomly selected American who moved was an owner or just a renter or a person who moved in the same state, etc., etc. There are a number of questions. If you look for these, you'll see what those questions are. Now, what this is called sometimes is called a contingency table. Okay? So I'm scaling this down a little bit so we can do a problem. The first problem that we're going to do is number 61. And 61 wants us to find the probability of somebody being an owner. And basically, I need to do that based on these observations here. And essentially, I just want to find the total frequency. Now, this is called a contingency table. And so what we can do is we can add rows or add columns as necessary. So all my owners, as you can see, are right here in this row. So because those are all my owners, I would like to add them up. So I take 11.7 million plus 2.8 million plus 0.3 million, and that leaves me with 14.8 million. So that's my total frequency. That's my numerator, or if you wish, the number in the set. So 14.8 million divided by, well, what would the total be? Well, it would be the total of all the movers. And the question is, if someone is a mover, what's the probability that they're a randomly selected American who moved? And so this represents all the movers. So what I need to also do is add the second row, 18.7, 4.5, 1.0, add those up. And we have 24.2 million renters who moved. And then I need to add these two categories. which will give me a total of 39.0 million. This is the total number of observations, or the total movers, and therefore that's my denominator. And so what's the probability that somebody who moved was an owner? Well, it's 14.8 million over 39 million, or if you wish, 14.8 over 39. And you can use a calculator to then change that to a decimal, which is also what you do typically when you do these problems. And that decimal is this number right here, 0.379, and your textbook will ask you to round to the nearest hundredth. So your answer would be 0.38. So it's approximately 38% of the movers were people who owned. So I've shrunk and moved that problem again, and what I want you to do now is do problem 62, which is, what's the probability of being a renter? Did you pause and try and do this? If not, pause now and do the problem. Okay, well, we already know that the total number of movers was 39 million, so therefore the number of renters would be the total of the renters, which I found before, which is 24.2%. And when I convert that to a decimal, I'm going to get 0.62, or 62% of the renters moved, or the probability that a renter will move is one of the movers is 62%. So they have some other questions there. For instance, 64 asks, what's the probability of a person who moved to a different country? So the probability of moving to a country, well, in that case, we would actually add this column right here for the numerator and get 1.3, but the total number of movers is still 39 million. And this would be our probability, and then we can convert that to a decimal or a percentage. And that's how you would do these problems. Okay? Be specific about what you're looking at. For instance, in 66, they talk about an owner who has moved to a different state. So owners that move to a different state is only this number, all right? Because the other ones are renters that move to a different state. So you can use these tables to write all kinds of probabilities. Well, to wrap up, here's our formula for empirical probability. It's really saying what's the number in the event divided by the number in the sample space, except we're saying what's the number of observations you see divided by the total number of observations. And that works. So we'll see you tomorrow, and hopefully you will have a good time doing these problems in class tomorrow.